everyone. My name is Avika Pal and today I am going to explain a fascinating topic, that is the Newton laws of motion, the laws that moves the world. So let's begin by saying some important points about the Newton laws of motion. Inertia. Inertia is the tendency of an object to resist change in its state of motion. Momentum. Momentum is denoted by P, the ability to keep increasing or developing, the force that makes something move faster and faster. It is a product of mass and velocity. Mass is denoted by m. This is the amount of stuff in an object. These points are crucial for understanding Newton's laws of motion. And here is the first law of motion, which states that an object remains at rest or in uniform motion in a straight line unless acted upon by an external force. Here is an example of the first law of motion. As you can see in this picture, that the ball will stay at rest until an external force applies on it. When the external force applies on it, the ball will start moving. And now we will see the second law of motion. According to the second law of motion, the rate of change of momentum of an object is directly proportional to the applied force and occurs in the direction of the force. Here is the mathematical form. F is equal to m into a, where F is equal to force, m is equal to mass and a is equal to acceleration. And here is the example. As you can see in this picture, that this is much easier to move an empty card in comparison to the loaded card, because the loaded card requires more force. Now we will see the Newton's third law, which says that for every action there is an equal and opposite reaction. The action and reaction forces are always equal in strength but opposite in directions. And here is the example of the third law. As you can see in this picture, that the man is applying force on the boat, that is moving it backward and with its feet, which is action, and the boat with this equal and same force applying to its this field, which is a reaction of this action. So here is the example of this. Thank you all for listening, and I hope this presentation helped you to understand Newton's laws of motion.
A very good morning to everyone. I am Khuzu Vista of class 9B. Today I am presenting my physics presentation on the topic of equation of motion. So let's start. Introduction of the terms we have to study. First term is motion. It refers to the change in object's position with respect to time. Second term is displacement, the shortest distance between the initial position and final position of an object. Third term is velocity. The rate of change of displacement with respect to time is called velocity. Fourth term is acceleration. The rate of change of velocity of an object over time is called acceleration. Fifth term is uniform motion. A type of movement where an object travels in a straight line at a constant speed is called uniform motion. Sixth term is non-uniform motion. A type of motion where an object travels unequal distances in equal time intervals is called non-uniform motion. Our first equation of motion is V is equals to U plus AT. Here stands for velocity, U stands for initial velocity, and time stands for T stands for time, and A stands for acceleration. So derivation of first equation of motion is as follows. So we know that the formula of acceleration is change in velocity time taken. So here BD is equals to V minus U, and BC is equals to V, and DC is equals to U, and OC is equals to T. So A is equals to change in velocity time taken. So here time with change in velocity is BD, which is V minus U, and time taken is OC, which is T. So acceleration is equals to BD upon OC, where A is equals to V minus U upon T. So we will shift, this is an upon, so we will take T in the multiply of acceleration. So AT is equals to V minus U. Here U in negative, when we will shift it, it change its sign and U will become positive. So AT plus V, U is equals to V. So this is the first equation of motion. Second equation of motion is S is equals to half AT square plus UT, where S is equals to displacement, U is equals to initial velocity, A is equals to acceleration, and T is equals to time. So derivation of second equation of motion. S stands for displacement. So displacement is equals to area of triangle ABD plus area of rectangle AOCD. So displacement is equals to half area of triangle B into H plus area of rectangle L into B. Area of triangle ABD is equals to half into breadth into height, where breadth stands for AD and height stands for BD. and area of rectangle AOCD, where length stands for AD and breadth stands for DC. So S is equals to half, where AD is equals to T. So we will write T in the place of AD, and in the place of BD we will write V minus U, as you can see in the graph. In AD we will write T, and in DC we will write in the place of V minus U AT from the first equation. When we multiply UT, we will write U into T, we will write UT. Displacement is equals to half AT square plus UT. So this is the second equation of motion. Third equation of motion is 2AS is equals to V square minus U square, where V stands for final velocity, A stands for acceleration, and U stands for initial velocity, and S stands for displacement. Derivation of third equation of motion. S stands for displacement, so displacement is equals to area of trapezium AOCB, as you can see in the graph. Displacement is equals to area of trapezium. So when we know that area of trapezium is equals to half sum of parallel sides into height, where parallel sides are AO and BC and height is AD, where in the place of AO plus BC we can write U plus V, and in the place of AD we can write T, where T is equals to V minus U upon A. Displacement is equals to half U plus V. Here we write in the place of T V minus U upon A. Displacement is equals to half V plus U V minus U upon A. And now we will shift A and 2 in the side of S, so it will become 2AS is equals to V plus U V minus U.
Good morning everyone. My name is Bhavna Bora and today I'll be presenting my presentation on the topic Newton's laws of motion. So the first law of motion is the law of inertia. An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. For example, stationary book. A book on a table will not move unless a force like a push or pull acts upon it. Newton's second law, law of acceleration. The acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass. F is equals to m. For example, car acceleration. A 1000 kg car accelerating at 2 meters per second square requires 2000 Newton of force to achieve the motion. Newton's third law, action-reaction pair. For every action, there is an equal and opposite reaction. For example, pushing a wall. When you push a wall with 50 Newton of force, the wall extracts an equal and opposite 50 Newton of force back on you. Real-world application of Newton's law. There are many places where Newton's law is required. For example, aerospace, automotive, engineering, and sports. For aerospace, rockets and orbital machines are directly governed by Newton's third and first law respectively. And for automotive, vehicles, acceleration, braking, and car crash safety are engineered based on Newton's second and first law. Conclusion: the timeless principle of motion. Newton's three laws fundamentally describes how force influences motion. They are indispensable for predicting and controlling movement across countless systems. Their elegance continue to inspire scientific inquiries and technological advancement, from the simplest falling apple to the most complex spacecraft launch. These laws govern our universe. Thank you.
Good morning everyone. My name is Makshi Sharma and I am presenting a presentation on the topic gravitation. Gravitation is a universal force of attraction that exists between two objects in the universe. It's not limited to massive bodies like planets or stars. Even two pencils lying on a table exert a gravitational pull on each other. Evaluate on information infinitesimally small one. This pervasive force acts across vast cosmetic distances, binding galaxies together, and also operates on the smallest scales, influencing the behavior of particles. Newton's universal laws of gravitation. There are three universal laws of gravitation.
Number 1, universal attraction. Number 2, proportional to masses. And number 3, inverse square of distance. Now let's talk about gravitation force. Gravitational force is the force of attraction between any two objects that have mass. It is one of the fundamental forces of nature and was first explained by Sir Isaac Newton. According to Newton's law of gravitation, every object in the universe attracts every other object with a force that is directly proportional to the product of their masses. Now let's talk about the universal constant G. While the gravitational force formula provides the framework, the universal gravitational constant, denoted as G, is as a precise numerical value that allows us to calculate the actual strength of gravity. It's a fundamental constant of nature, meaning its value is the same everywhere in the universe, irrespective of location, time, or the other type of masses involved. The accepted value of G is approximately 6.674 into 10 power minus 11 Newton meter square per kg square. This extremely small number highlights that gravity is a relatively weak force compared to other fundamental forces like electromagnetism. Now let's talk about free fall. Free fall is the motion of an object falling under influence of gravity alone, with no other forces acting on it, such as air resistance. When an object is in free fall, it accelerates towards the earth with a constant acceleration called acceleration due to gravity, denoted by G, which has a value of approximately 9.8 meter per second square. During free fall, the object's speed increases continuously, and its motion can be described using the equations of motions by replacing acceleration A with G. For example, a stone dropped from a certain height falls faster and faster due to gravity, showing a typical case of free fall. Now, let's talk about mass versus weight. Mass and weight are two different physical quantities. Mass is the amount of water present in an object. It is measured in kilograms and remains constant everywhere in the universe. On the other hand, weight is the force which gravity pulls an object towards the center of the earth. Weight depends on both mass and gravity and is measured in newtons. The formula of weight is weight mass into acceleration due to gravity. That means if gravity changes, the weight changes, but the mass remains the same. Simply we can say mass is constant and weight can change. Now let's talk about gravitation in our lives. Gravitation, seemingly simple yet profoundly complex, is not merely a concept confined to textbooks and classrooms. It is an omnipresent force that profoundly impacts every aspect of our existence and the universe around us. Its influence extends from the smallest everyday occurrence and the greatest cosmic phenomena. Keeping us grounded, it is the function. Let's talk about the functions of gravity now. So like we can say, keeping us grounded, influencing tides, orbits and satellites, formation of cosmic structures. From the apple falling from a tree to the majestic dances of galaxies, gravitation is the invisible yet ever-present orchestrator, continually shaping our world and the vast expanse of the osmosis. Understanding it is fundamental to comprehending the universe wasn't inhabited. Thank you so much for giving me a special time and have a great day.
You like the video, like, share and subscribe our channel.